So for our next talk, we're going to get something really exciting. And I think we already all know NVIDIA and how the generative AI wave has really accelerated NVIDIA's rise to become the most valuable company in the world. And so it's just really exciting to see that they're still doing a ton of work and giving back to the open source and developer ecosystems. And today we're going to get to hear from Jay Rodge about exactly how NVIDIA is doing that work. So Jay, the stage is yours.
Thank you, Jujian, and thanks for the opportunity. Hi, everyone. Good morning, good afternoon, wherever you're in the world. I'm Jay. I am a developer advocate at NVIDIA focusing on large language model. And I'm really excited to talk to you about what are the LLM workflows that NVIDIA GPUs can accelerate. And if you already are working on an LLM pipeline, there's tons of stuff that you can use to accelerate it on GPU. So let's get started. So we all know, like, generative AI has been transforming everything that we are doing. It can basically learn and understand any kind of data, and that is also affecting how developers are creating application, introducing a new wave of tools and application and use cases that we never thought uh, could happen. For example, think about chatbots from 5 years in the past. The way we do, the way we used to do chatbots was using BERT or any other transformer, basically understanding what's the intent of the query by using named entity recognition and then doing all kinds of uh, tasks after that. But with LLMs, it has significantly simplified how you can design a workflow for any kind of use case. And at NVIDIA, we are committed to providing a comprehensive platform that helps a developer get the best user experience by making it faster and cheaper. So let's look how NVIDIA has, what options does NVIDIA have? So we provide a full stack accelerating computing platform, which is purpose built for LLM workloads. And this includes a combination of hardware, specifically GPUs, which NVIDIA is well known for, but also software and services designed to help you develop, train, and deploy AI models efficiently. And we constantly work with the open source ecosystem to add support and integrate all the NVIDIA software optimization into those frameworks so that the end developer doesn't have to care about the low level layer that might be for expert developers. So today I'll dive in deeper about what are the layers about which developers can participate or just use. So so let's start with the system optimization. So we provide cutting edge hardware such as GPUs, but also we recently introduced Grace CPUs as well. And there's also networking, which we have as InfiniBand, and then DPUs, which is specifically designed to handle AI workloads efficiently. And then to manage and orchestrate these workloads, we also are integrated within Kubernetes and Slurm, which take care of managing and orchestrating these workloads. From NVIDIA side, we also provide Base Command Platform or BCP, which seamlessly offers a streamlined experience for managing AI tasks. And when we go to the library layer, we provide optimization libraries like CUDA, TensorRT LLM, and Transformer Engine, which play a really crucial role in optimizing whatever kind of model you're trying to run, maximizing the performance and scalability. And we keep adding new libraries such as XLA and Ray to get the best performance. Moving up on the model architecture and technique side, we also are integrated within PyTorch and Hugging Face transformers that facilitate the development and deployment of LLMs. And We also enhance these capabilities with our own NEMO framework, which I'll talk in depth about in the later stages. But it offers comprehensive tools for model training, customization, evaluation, and safety. And in terms of model, like ecosystem is really good nowadays. Like there's new foundation model being released or a new update being released every other day or every week, such as llama 3, Mistral, and they provide range of capabilities for various kind of use cases, and all of them are optimized for NVIDIA GPUs. And we also have some specific models like Nemo models within NEMO umbrella and Biomegatron, which are tailored for specialized domains, ensuring that you have access to the model optimized for your specialized use cases. And at the top layer, which is application, developers can make use of libraries like LangChain, llama Index to simplify the integration and the management of LLMs within application. And we also have great partners like OpenAI, AWS, Google, and Microsoft who have their managed APIs, which are also using NVIDIA GPUs behind the backend. So this was the overview about the full stack software ecosystem. So developers are free to choose at whatever layer they want to interact. If you are an expert developer, if you care about the maximum performance optimization on NVIDIA GPUs, you can use XLA, CUDA, or TensorRT LLM. But if you just want to make sure that your pipeline works and it's easy to use, then you can interact with LangChain, llama Index, which also have integration for lower level libraries. So let's switch gears and see, like, if you are building a LLM application today, how NVIDIA tools can help you on the training and the inference aspect. And today I will talk about NEMO framework for training and customizing your model, and the inference software that we have, which is TensorRT LLM and NVIDIA Inference Microservices. So NEMO is our framework for building, customizing, and deploying LLM large language model application, and it includes all the bits and pieces that you might require to build your own LLM and deploy that as well. Starting with data processing, we have NEMO Curator, which simplifies the entire data processing workflow, which consists of data extraction, deduplication, and filtering, which ensures high quality data for training. And we also have Customizer, which includes variety of fine tuning techniques, which I'll talk about later in this slide. Then there's also Retriever, which helps you create a GPU accelerated RAG pipeline, and guardrails as well to limit and evaluate your responses before delivering it to the end user. And once you are done with model building and adding guardrails, you can deploy that with NIMS or integrate that with NVIDIA Triton, which is an inference serving solution for accurate, low latency, and high throughput inference. So let's talk about the customization part. So if you have a specific use case which the generalized model doesn't help you get specific answer, then you can choose to do some form of customization, and Linux supports customization in all formats, starting from prompt engineering, where you can use few shot learning and system prompting, which achieves quick result with minimal data and investment, all the way up to SFP, or the popular method currently is parameter efficient fine tuning, or PEF, where you can use tools like adapters and LoRa to target specialized training for peak performance with moderate investment. So depending on your use case, you can choose the right customization path and get the best accuracy for your use case. Once you have customized the model, next step becomes adding guardrails to keep the solution to keep the solution that LLM generates accurate, appropriate, and on topic and secure. And NEMO guardrails is open source and is accessible to all developers. It's also easy to implement and integrates with all enterprise tools like LangChain, ensuring a powerful yet safe environment for LLMs. So NEMO is also good in terms of ecosystem. We have ton of integration with all the popular libraries or tools that you are using today, and it can be all on GPU. So that's great, which makes sure that you have the least possible latency for your application, which ensures a good user experience. So once the model is trained and you have all the guardrails in place, then it is time to deploy. And deployment has its own challenges because there's new model being released every other day, and it can be sometimes hard to optimize or integrate those new models into your existing pipeline because those models might have new architecture or they might continue to evolve. So we need a robust, extensible solution for uh, LLM deployments, and the answer to that is TensorRT LLM. It is our open source library that optimizes large language model performance for production deployment. And as an FYI, this is an extension to the deep learning inference SDK called TensorRT, which has been there for, I think, almost 6 to 7 years now. And it is already good at optimizing NLP vision-based model, but this specific extension works on the large language models performance, which provides additional features like state-of-the-art performance by using TensorRT compilation and optimized kernel for your target GPU. And if you have a custom model, you can use the Python API from TensorRT LLM to quickly add new operators that can get accelerated on NVIDIA GPUs. And if you want to have various batching requirements, you can use it with Triton that maximizes the throughput and GPU utilization. So let's look how TensorRT LLM works. So it's mainly three-step process where you load the model. Once you have the model, you create or generate an engine. So the engine building process is basically TensorRT looks at the model graph and tries to see what layers of the model can be fused together so that it can be run faster on NVIDIA GPUs. It also tries to look at what kind of hardware you have. So it tries to see what specific GPU feature it can use. For example, Hopper architecture has FP8 precision. So TensorRT can immediately recognize and try to optimize based on that precision and hardware feature. And once you have the engine file generated, you can then execute that with TensorRT runtime or just load that into Triton Inference Server, which gives you ability to deploy in Python or C++ API. So this is an example of how you would do that in terms of code. So on the right-hand side, first you will install and build TensorRT LLM, and then you download these model checkpoints from model hub of your choice. In this case, it is Hugging Face. And once it is done, you can generate the engine using TRT-LLM dash build. And once you have .engine file generated, you can use that with TensorRT runtime or Triton to inference. So in this case, it is using a sample script run.py from the TRT LLM GitHub repository to do one inference. So this was the process to do TensorRT LLM inference optimization. But if you are looking something easier, we recently introduced NVIDIA Inference Microservices, or NIMS in short. We announced this earlier this year at GTC, and this also got a mention in a recent Jensen's keynote at Computex. So this provides a containerized solution for deploying optimized LLMs with just a single command, which significantly reduces time and engineering resources required for model optimization and deployment. So let's see how it works. So Think of NIM as a delivery package optimized for your specific hardware, which makes the model deployment fast and efficient. So it handles your hardware configuration, allowing you to choose and deploy the model you want. And each NIM container is tailored to specific LLM, featuring a base container image and a lightweight model configuration layer, which ensures quick deployment and the best performance on NVIDIA GPUs. So going in depth, so a NIM container features an OpenAI compatible API layer with fast API, which enables seamless integration with your existing code. And the requests are efficiently processed by optimal runtime, which could be either TensorRT LLM or VLLM in the backend. And it can be served back in batch or streaming mode. So the performance using NIM is quite significant. So if you just use Llama 370B instruct model on NVIDIA GPU with NIM on, you can get up to 5x performance boost if you use the same model on NIMs without doing anything, just a single command, which significantly improves the performance, but also lowers the TCU. So to summarize, NVIDIA NIM significantly reduces the time and effort by providing pre-built optimized engine for both NVIDIA and community model. And it also automates the deployment, and we also provide enterprise-grade support if required, which makes it the fastest and most efficient path to AI inference for developers and organization. So this was training and inference, but there have been so many applications, but RAG has been at the top in terms of real world use cases for large language models because its ability to connect LLMs to up-to-date information and knowledge bases. So NVIDIA also provides an optimized RAG pipeline that includes accelerated embedding, de-ranking, and personalization components. And it integrates seamlessly with popular frameworks like LangChain, Llama Index, as well as popular open source vector databases like Milvus and Redis. So this integration allows developers to build highly accurate and performant RAG application with minimal effort. So yeah, that was for on the training and inference side. We have a ton of tutorials on this. So these are some getting started guide. I would recommend go to the GitHub repository for each of them to get up and running. There's also a dedicated repository called NVIDIA Generative AI Examples, where you can see pre-built POCs or sample reference application built using NVIDIA and open source integration. And it also includes NIM as well, NIM deployment. And we also have Deep Learning Institute or DLI, which can help you get started and ramp up quickly on some of the foundational topics on large language models and generative AI. And you will also get a certification if it is necessary for you. So to summarize, NVIDIA provides a full stack solution for LLM deployment from hardware to application frameworks. It's up to you, whatever you want to choose from the whole layer. Like we are integrated in most of the popular open source frameworks. And on the training and inference side, we have tools like NeMo, TensorRT LLM, and NIMS, which enable developers to build, optimize, and deploy state-of-the-art large language model application efficiently. And we also have ton of ecosystem integration, and we are committed to supporting the developer community with integration for popular libraries and framework as they get launched or used. So that was it from my side. I'm open for questions now.
Thanks, Jay. I have some questions for you. We'll see if the audience has any questions as well.
Sure.
What are you most excited about in this whole like development of LLMs and how it relates to what you've been doing at NVIDIA?
That's a good question. I think we are still at a stage that we haven't. I'm not talking from NVIDIA's perspective, but as a fan of generative AI in general, I feel like we still haven't found out that killer use case. Like we have ChatGPT, we have chatbots, but I think we are still figuring out on how to integrate those tools in our daily life. Being as a software engineer, being as a product manager, like yes, we are using ChatGPT, but I think there will be a time there where it will be seamlessly integrated within our workflow that it would be so hard to imagine our life without those. For example, I think data copilot could be one of the good use cases. But yeah, I'm excited for what's upcoming.
Very cool. And then like in your time at NVIDIA,
Mm-hmm.
so you've been at NVIDIA for a little over 4 years now, right?
Correct. Yeah, that's correct.
Yes. Okay. Yeah, I saw your post on LinkedIn. So what have you been seeing over the maybe like the last like year or two that has been like kind of different? Have you seen anything that's been happening internally that's been different because of the whole generative AI stuff, or I don't even know if you're allowed to tell us about this stuff. What have you been
Mm-hmm.
kind of like seeing internally? Is there anything exciting that we should be on the lookout for?
Mm-hmm. Mm-hmm. Yeah. So I think in last 1 years we have been impressed about the community models and how good they are getting. Like every I think every week or every 2 weeks there's a new model which beats the benchmark of the other model. So it's really good to see, and we are actively work with those partners and model providers to optimize those on NVIDIA GPUs. So I think there's two trends that model sizes are getting smaller and smaller, which
Okay.
also makes it easier for uh, developers to have locally running applications. For example, I think Apple Intelligence, like we have optimized the model so good that it can run on our local devices. So RTX AI laptops, we provide features like background blur and reducing noise from your video as well as audio. So it is all happening locally, so you don't have to rely on crappy AI tools from other providers or the tools that you are using. So yeah, so
Okay.
excited about that.
Very cool. What do you think about? Have you had the chance to try out like like many of the open source models on the NVIDIA GPUs?
So I would like to share my experience with Olama. So
Okay.
Olama is one of the uh, model hub slash. It helps you basically run models locally on your GPUs or CPUs. But I think I try to integrate that with my VS Code using continue.dev extension. So it has been working really well. I can also have my local chat GPT kind of application all running locally thanks to Olama, and the models are optimized. So I think, yeah, I'm excited about that aspect, that having everything local is great because I don't have to worry about sending my data to some cloud server. So yeah, everything happening locally, I think that would be a great step forward. And I think we are trending towards that future, and it would be here, yeah, sometime soon.
So I think one of the things about LLMs and generative AI that makes it difficult for a lot of people, and so I talked about this earlier, is like this ability to
Hmm.
access GPUs and how not everybody is able to get access to GPUs because
Hmm.
uh, I mean, there's just a limited quantity, right? So,
Hmm.
uh, and you were talking about how the one of the trends that you're seeing is that some of these models are getting smaller over time. And so, one of the things that I would like to ask you about is how do you see, how do you see this in terms of like what you guys are doing, and maybe like the role of what NVIDIA used to build, which I guess you guys still technically build, but like things like the RTX, GTX, like what if you're a gamer, like if you used to play video games, I built my own PC. I used to like to play like video games on my PC, and so
Mm-hmm.
I would use these, I guess they call them consumer GPUs now.
Correct.
How do you see like the role of like these different GPUs play out as we move towards different models? Like, do you think there's still going to be room for like these larger models that are going to be doing a lot of stuff as well as smaller models? Like, how do you kind of see this play out?
That's a good question. And I think from my point of view, so all the great GPUs, data center GPUs we have, Hopper and Ampere, and the new one is Blackwell is upcoming. So all the features are being transferred to the consumer level GPUs like
Okay.
GeForce, for example, FP8 precision or the transformer engine. So developers can still use those or get the benefit of those features on GeForce GPUs like 40, 80, 40, 90. So you get to use those features, build AI application, as well as you also get to play games which has generative AI inside it. So for example, DLSS, deep learning super sampling technique, which is part of the gaming toolkit that NVIDIA provides to all the developers. You can use that to like use generative AI to improve the frame rate of your game. So it basically generates. So if you have a demanding title, then it might just give you 25 to 30 frames per second without using DLSS. But if you use DLSS at runtime, it will generate the frame in between and make you or boost the frame rate to maybe 60 or 90. So that's also a form of generative AI. So you get to game with a high quality uh, image as well as experience, but you also get to uh, use generative AI in your for productivity tools like not ChatGPT, but VS Code. So I think it's beneficial for those kind of developers who are also gamers. So yeah.
Oh, that's really cool. I didn't even, this is like my first time hearing about that. I didn't know that you guys were doing work around that as well. And does this work like with like online games or like offline games?
So it's I'm not so sure. So we do have cloud gaming uh, service that NVIDIA offers. I think it might be using DLSS, but for offline or local gaming, it is for sure like you can use it. There's a setting in your game called DLSS off or on, so you can just turn it on. And I think most of the popular games support DLSS, and we keep adding them. Uh, yeah, with time. So.
Okay. Wow. That's really cool. This is like, I love that we're always like get to learn about something new from this.
Mhm.
So I don't think the audience has any more questions. I think we can move on to the next talk unless there's anything else you want to say in the next couple minutes, Jay.
No, I'm really excited about this conference. Thanks to you for organizing this, and also excited what developers feel about NVIDIA software and what's their experience. So do feel free to share with me on LinkedIn or any other platform. We are also on Discord if that's your preference. But yeah, I'm always all ears.
Okay, cool. Awesome. Thank you for coming, Jay.
Bye bye.
See ya. Thanks for coming.